Okay, now we will see the directions of the aero cap and a Fi cap. As I said earlier, by having the values of rho and phi, we have represent the point like this. Here the point is available, and at this particular point, if it is a vector, we have to represent the direction of the aero and a Fi. As I said earlier, now we will take this example. Here already I have mentioned the aero direction is this side and a Fi direction is this side, in this direction. How it is possible, you see. Aero is perpendicular to rho is equal to constant. So, rho is equal to constant means that is a circle we have drawn. At this particular point, perpendicularly aero cap is available, that is the thing. If the point is here, radially outside it should come. Perpendicularly means like this also you can able to draw, but it is wrong. It should come radially outside. If the point is here, perpendicular means this side. Okay, in this manner, if the location is changing, if the point location is changing, the direction of aero cap is also changing, but it is not true in case of the Cartesian coordinate system. I have mentioned at that place also. In case of the Cartesian coordinate system, irrespective of the positions of the points, the unit vector directions are not changed. But in this case, if you change the position of the point, the direction of the unit vectors will be changed. Okay. So, coming to this a Fi cap, this is a straight line, the point is here. So, this is a straight line means this is representing phi is equal to 45 degrees. So, a Fi cap is perpendicular to phi is equal to 45, phi is equal to constant. Generally what we will tell, a Fi cap is perpendicular to phi is equal to constant. Phi is equal to constant means straight line only. For that straight line, this a Fi cap is perpendicular. So, this is the direction of the a Fi cap. So, that we have given like this. Otherwise, if the point is here, I have given one more example here. So, this is the point, and for the circle a Fi cap is perpendicular. For the straight line, a Fi cap is perpendicular. You can take any other example also. For example, the point is here, the point is this one. So, what is the direction of aero cap? This is the direction of aero cap radially coming outside, and what is the direction of a Fi cap? That is this one. People will get some doubt here. Aero and a Fi is also perpendicular, otherwise I said that aero is coming radially outside. So, it will come outside of the circle. So, it will not go inside, that is okay, there is no doubt regarding the aero, but doubt will be there regarding a Fi. Perpendicular to the straight line means this side we can take or this side also we can take, but which is correct? Only this one is correct, this is correct, this is wrong. If you say this is a Fi cap, this is wrong. What is the reason? Means we have to follow right handed coordinate system. Okay. So, if you perform the cross product in between aero cap and a Fi cap, you should get az cap. This one you will be understood in the 3-dimensional cylindrical coordinate system. In case of the cylindrical coordinate system, the third coordinate will be added, that is z, along with this rho and phi, the third coordinate will be added, that is z. So, the cross product in between aero and a Fi should provide az cap. If you come to towards phi from the rho, this is representing the z direction, right handed system we have to follow. So, with respect to x, y, z, this is x axis, this is y axis, this is z axis. These things we will see in our 3D coordinate systems. X axis coming out of the plane, but that one we are representing like this, and the plane itself is the yz plane. Okay. So, if you move from x to y in your right hand curl, if you represent your right hand curl in such a way that you are moving from x to y, the thumb of your right hand is representing the z direction. Similarly, the curl of your right hand, the 4 fingers of your curl, right hand curl is representing from A row to A5, then your thumb is representing the AZ, like that we have to take. So, with the help of that third coordinate you can able to understand clearly why this A5 cap direction is correct, why this A5 cap direction is wrong. Okay. That is the thing. Regarding the unit vector directions also we have completed in case of the 2-dimensional polar coordinate system. Now, coming to this 3-dimensional coordinate systems. So, one glance I have given here, Cartesian coordinate system or rectangular coordinate system. As I said earlier, the point is represented by 3 coordinates x, y, z, and in case of cylindrical coordinate system the point is represented with rho phi z, and in case of the spherical coordinate system the point is represented with r theta phi. So, in case of Cartesian coordinate system, one box can be represented as a space. The space itself is assumed as a box, rectangular box, but in case of cylindrical coordinate system the space itself is assumed as a cylinder. In case of the spherical coordinate system the space is assumed as a sphere. And here this is the way of representing the point in case of the rectangular coordinate system, rho phi z, sorry x, y, z. But here x is equal to constant means you do not think that it is a line, it is not a line in case of 3D, do not confuse here. We have seen 2-dimensional Cartesian coordinate system where x is equal to constant means it is a vertical line, but in 3D x is equal to constant means it is not a line, it is a plane. Okay, that is a yz plane, the plane parallel to yz, otherwise we can tell like that. And y is equal to constant means it is also a plane. Which plane? Xz plane. Y is equal to 0 means exactly xz plane. Y is equal to constant means the plane parallel to xz plane. Similarly, we can able to take z is equal to constant or z is equal to 0 plane. Okay, so all these things are planes. The intersection of these 3 planes, x is equal to constant, y is equal to constant, z is equal to constant, is representing the point in the space. This is the way of representing the point in the space by using the 3-dimensional rectangular coordinate system. Compared to 2-dimensional Cartesian or rectangular coordinate system, here extra quantity or the extra coordinate is the z, that is providing the height, like that we can able to tell. So, generally this is x axis, this is y axis, this is z axis. The screen or on your paper is represented by this yz plane. The x axis is coming out of the plane, otherwise the same thing can be represented like this also. This is y, this is z. X is coming out of the plane, that is represented like this, dot circle. Why dot circle means vector is having the arrow, this is the head and this is the tail. If this arrow is coming towards you, you will see only this point only, that is this one. That means positive x axis is coming towards you from the paper, from the screen it is coming towards you. You will observe only this node you will observe, that arrow point only one point you will observe, that is why the here x axis is represented like this. The same representation is this one also, but we are drawing the 3 coordinates on a 2-dimensional plane. So, it is difficult to draw, difficult to represent, so that we will take the z axis, x axis is like this. But whenever you are seeing this type of diagrams, you have to assume x is coming towards you, x is coming out of the paper, x is coming out of the plane, like that you have to visualize. In these 3 diagrams you have to see like that only. Okay, that is the thing. Now, coming to the second one, that is the cylindrical coordinates. So, one point in the space can be represented using this cylindrical coordinate systems. For that we need 3 coordinates. rho phi z. Here rho is nothing but not a radius of the circle. Here rho is nothing but radius of the cylinder, because if you fix rho, phi and z are changing. Previously only phi is there, z is not there. So, if you fix rho value, rho is constant, phi is changing from 0 to 2 pi, then that is representing a circle. That one already we have seen. But now along with phi, z is also changing. Z should change from minus infinity to plus infinity. So, rho is fixed, you will draw a circle by changing the phi value with 0 to 360, but z is also changing now. Z is changing from minus infinity to plus infinity, or for simplicity I am taking from 0 to 5 meters. Then this cylinder has been created. So, in how the cylinder is created, that you need to see. It is not only because of the fixing the value of rho, it is because of all the values of phi and all the values of z. Rho is equal to constant means what about remaining two variables, phi and z? Phi is taking all the values from 0 to 360 and z is taking all the values from minus infinity to plus infinity. Because all the values are involved, phi values and z values, that cylinder has been created with the radius rho. Okay. Similarly, when you fix a phi value, rho value should change and z value should change. When you fix z value, rho value should change and phi value should change. Rho and phi will take all the values when z is constant. When phi is constant, rho and z will take all the values. So, phi is equal to constant means in 3D it is not a line. Phi is equal to constant means we have taken previously, that is a line, angle measured from the positive x axis in anti-clockwise direction, that is the definition of the phi in case of 2D only. But in case of 3D, phi is equal to constant means rho should change from 0 to infinity and z should change from minus infinity to plus infinity. So, this is representing a sheet. How can you get a sheet? This is the sheet actually. This is a sheet created because of the fixing the phi value. Here you see rho is changing like this, z is changing like this. When you fix a phi value, this angle is the phi, that is fixed, but rho is changing and z is also changing. Because of the change in rho and z, that sheet has been created. Okay. This can be understood in different way also, that I will tell here. X axis, y axis, you are fixing the phi value, this line has been created, this one already we know. Now, you assume z is coming out of the plane. Okay. So, on this line z is equal to 0, or on this plane z is equal to 0, xy plane means z is equal to 0. Now, z value is changing, for example 0 to phi. So, on this line one more line is there, on this line one more line is there, on that line one more line, one more line, one more line, like that line by line is available from z is equal to 0 to phi. That means, you will observe a sheet. So, for that we will take this diagram now. So, phi is fixed 45 degrees, you will draw a line. How, what you are seeing here, the line, this is x axis, this is y axis, that line is this one only. On the xy plane this line is available. Now, one more line is required because z value is changing, one more z value is changing, one more z value is changing, z value is changing like this. So, that finally you will observe a sheet like this. Okay. So, phi is equal to 45 means this is the sheet you can able to observe. For example, this is x axis, this is y axis, this is z axis. Now, phi is equal to 0, it starts from x axis only or xz plane only. So, phi is equal to 0 means like this you have to draw the sheet. Phi is equal to 45 already I have drawn here. Phi is equal to 90, phi is equal to 90 means that is yz plane only. phi is equal 90. Like that, if you change the phi value, that sheet is rotating with respect to the z axis. Around the z axis, that sheet is rotated. The visualization of how the phi is equal constant sheet is rotating. If you increase the rho value, how the cylinder radius is increasing, all these things you have to visualize, then only you can able to have the clarity. Now we will see how to calculate the volume in case of the Cartesian coordinate system. Dx is a differential movement in the x direction, dy is the differential movement or differential length in the y direction, dz is the differential distance or the movement in the z direction. Volume is created because of the multiplication of the 3 dimensions. So that because all these things are differential elements, the differential volume dV is given by the product of these 3, that is dx, dy, dz. How much distance you have moved, if it is given in the x direction, in the y direction, in the z direction, then you can able to get total volume also by integrating this particular thing. So that is what here we are seeing. So total V is equal to integral dx, dy, dz. So they have given that x value is changing from 0 to a, y value is changing from 0 to a, and z value is changing from 0 to a. It is a volume integral. So it is equal to, you can take that one, integral x is changing from 0 to a dx, integral y is changing from 0 to a dy, integral z is changing from 0 to a dz. So it is equal to, we can write volume is equal to integral of 1 with respect to x is x, limits are 0 to a, integral of 1 with respect to y is y, limits are 0 to a, integral of 1 with respect to z is z, limits are 0 to a into a into a, if you substitute the limits you will get a cube. This is actually the volume of the cube, and cube of the side we have assumed as a. So in each side you can able to see a length will be there, so that we can able to take dx is actually a, dy is actually a, dz is actually a. So you can see this particular diagram here. Okay. So this is the y axis, this is z axis, this is x axis. So in the x direction the change the length of that particular side is a, in the z direction also a, in the y direction also a. What is the volume of that particular cube is nothing but it is given by a cube. In this manner we can able to find the volume of the cube also. So here we have given about the differential length, differential surfaces and differential volume. As I said earlier, you are moving from one point, that is from for example 2, 3, 4 to another point where 5, 6, 7 is the coordinates. You are moving from here to here. How the x value is changing? 2 to 5, y value is changing from 3 to 6, z value is changing from 4 to 7. So there is a change in x 2 to 5, that is dx. There is a change in y 2 to 3 to 6, that is dy. There is a change in z, that is 4 to 7, that is dz. So what is the differential length vector in the x direction? Means dx ax cap, how much change is there, that one we are taking as a magnitude, that is dx, and in which direction it is available, x direction, that already we know. And what is the differential length vector in the y direction? dy ay cap. What is the differential length vector in the z direction? dz az cap. What is the total differential length vector? There is a change in the x, there is a change in y, there is a change in z. So in 3 directions change is available. So total differential length vector is given by dl bar is equal to these 3 additions we are taking, dx ax cap, dy ay cap plus dz az cap. In that process only the surface area vectors also generated. So surface is having one interesting point. In case of the lengths, if you move along the x direction, differential length vector you have created, that is the dx ax cap. If you observe one thing, in which direction you are moving, the distance vector is also having the same direction. That means in x direction you are moving, your differential length vector direction is also having ax cap only, dy ay cap, dz az cap. But the surface is created because of two variations, two direction movements, but the surface direction is perpendicular to that one. That is the point we have to remember. For example, here first one I am explaining here, dy dz, there is a change in the y direction, there is a change in, or there is a movement in the y direction, there is a movement in the z direction. So, that particular surface has been created because of the change in y and because of the change in z, like this you can able to take. But what is the direction of this particular surface means perpendicular to this one. The surface has been created because of the changes or because of the values of y and because of the values of z, but the direction of surface is x direction. Okay. That is why the surface is a vector, first of all that is a vector having the direction perpendicular to it. Surface is a vector having the direction perpendicular to the surface. Surface has been created because of y and z, that is why dy dz, but direction is given by ax cap, the suffix is representing the direction only. So, ds x means that is the differential surface having the direction x and has been created because of the changes in y and z, that is why dy dz ax cap. If I say ds y, it has been created because of the changes in x and changes in z and the direction is given by y direction. ds z is nothing but that is the product of the distance vectors dy and dz having the direction x direction, sorry z direction. And next volume. Volume is a scalar, this is the thing you have to remember. Volume is a scalar quantity, but length and surfaces are vectors. So, volume is generally created because of the multiplication of the 3 dimensions. So, differential length dx is there, differential length dy is there, differential length dz is there. If you multiply these 3, the volume will be created. The same thing will be followed in remaining 2 coordinate systems also, like cylindrical coordinate system and spherical coordinate system, but the differential lengths will be changed. Okay. So, in case of Cartesian we are telling dx, dy, dz, but in case of cylindrical we need to say d rho, d phi, dz, but whenever angle is involved, d phi, that is not a length. So, for that we have to take more care. Okay. How we can able to make differential length vector because of the change in phi, that we are going to see. Before going to see about that one, here about the surface we have one small problem. So, this is a x direction, this is y direction, there is a change in x from 3 to 7, that means how much distance is there, 4, how much change is there means 4, that is nothing but dx. There is a change in y also, that is 2 to 4. So, dy is equal to that is also 4. What is the area? Multiply these two, that is 8, that is 4 into 4, that is 16 you will get. Okay. So, that is what we are doing here. Integral x is changing from 3 to 7, integral y is changing from 2 to 6, the change is there for the x, change is there for the y, that is what we have given here. You can able to do that one, you will get 16. But on this particular thing z is fixed, okay, we did not talk about z also. So, z is fixed. Now, it is about the cylindrical coordinate system only. I said earlier this particular blue thing is representing z is equal constant plane and this plane is representing phi is equal constant, and cylinder we did not show in this particular diagram, cylinder you can able to visualize here. Okay. So, how to represent a point using this particular coordinate system, that we will see. This is x axis, y axis, z axis. If I give rho and phi, you can represent a point. If I give rho and phi, you will represent a point like this. this is rho phi, this is xy plane. So, z is 0. Now, z value also I am providing. So, z is nothing but vertically upside we have to go. So, like this we have to travel, this is the z value, that means z is added to that rho phi. So, rho phi z, like this will represent. For clarity we will take this one also, this is rho, this is z. Instead of including this z quantity, you can see the xy plane like this also. Now, z is coming outside. So, z we can take like this. So, this is rho actually and this is phi. The same point rho phi can be represented using xy also in case of Cartesian coordinate system. So, this is a line, this is a line, this is our x value, this is our y value. So, here one right angle triangle has been created with sides x y rho, and here one acute angle is there, that is phi, and 90 degrees is available here. Because it is a right angle triangle, we can apply the trigonometric functions. So, here you can able to apply cos phi is equal to x by rho, x is adjacent side, rho is the hypotenuse, sin phi is equal to y by rho. So, you can able to write from here x is equal to rho cos phi, y is equal to rho sin phi. So, if you have rho phi, you can calculate x y like this. Otherwise, apply Pythagoras rule. What is the rho value? Rho is equal to square root of x square plus y square, and phi is equal to, using y x, how to tell phi value? Tan inverse of y by x. So, if you have x y, you can get a rho phi. So, the point can be converted. If you have the point in cylindrical coordinates, you can get the point in the this Cartesian coordinates, or if you have the point in Cartesian, you can get the coordinates in the cylindrical, that is the thing, and anyway z value is same. But one thing I will tell, that is converting the point from cylindrical to Cartesian and vice versa is different from the converting the vector from the Cartesian to cylindrical or cylindrical to Cartesian. Do not think that both are same. Here I am not discussing about converting the vector which was given in the Cartesian into the cylindrical and vice versa. Okay. And for example, we are in now cylindrical coordinate system. With respect to 2 dimensions, I will tell otherwise. This is x axis, this is y axis. We will take here this is some phi is equal constant, and if the rho value is this one, with this circle we can able to represent, this is the point rho comma phi. Okay. Then if this is the rho, if rho is increased by some amount, this is rho 1 and this entire length is rho 2. What is this length? Rho 2 minus rho 1, that is itself is called d rho. Now, you observe one thing, rho is a actually distance, okay. It is a radius of the circular cylinder in 2D circle, in 3D cylinder. It is a distance measured in meters, for example. So, if you change, if you have the change in rho, that is also a length, that is also measured in meters only. So, that is d rho, that is what this one. Along with this one, this is rho, along with this one, here some phi is there, phi 1 I will take. For this phi 1, here one arc has been created, arc length is L1. Now, what we will do in the sense, I am changing the phi value, phi 2 I have taken, this is making phi 2 angle with respect to positive x axis. For this phi 2, the arc length is different, that is L2. Okay, but rho is fixed, okay, radius is fixed, phi only phi I am changing. For phi 1, the arc angle is L1, for phi 2 arc angle is L2. Now, what we need to find in the sense, what is the differential length due to the change in phi? If phi is changing, what is the differential length you are getting? That means phi 2 minus phi 1 we have to take, that is equal d phi, which leads to L2 minus L1, that leads to dl. Actually, angle is equal to arc length by radius, arc length by radius. So, based on this, phi 2 is equal to L2 by rho, phi 1 is equal to L1 by rho. Take the change, d phi or phi 2 minus phi 1 is equal to d phi, that is equal to L2 minus L1 means dl by rho. Now, dl is equal to what we can able to write? Rho d phi. This is the important one for us. Because of the change in phi, how much change you are observing in the length means dl. In case of Cartesian coordinate system, if x is changing, the differential length we have represented with dx only. If y is changing, differential length we have represented with dy. If z is changing, differential length is represented with dz. This is about Cartesian coordinate system. Now, coming to cylindrical coordinate system, if rho is changing, differential length is given by d rho. I said already, this is a length, for length there is no problem. But if phi is changing, what is the effect on the length? Phi is the angle, but I am asking for the differential length. This is the relation, this is the relation. If phi is changing, what is the differential length means? Rho d phi. This is the thing you have to remember. X is changing dx, y is changing dy, z is changing dz, rho is changing d rho, but phi is changing means rho d phi. Phi is changing means rho d phi, this rho will come extra. Similarly, z is changing means z is a distance, so simply dz is enough, over, that is the thing. And I have given the reason also why this rho is coming extra, means this is the reason. If you change the phi value, arc length is also changing, that is what we are getting here. And z range already we know, that is from minus infinity to plus infinity, z is from minus infinity to plus infinity, phi is from 0 to 2 pi, rho is from 0 to infinity, these things already we know. Volume of the cylinder, now it is the time to calculate the volume of the cylinder, that one we can able to get, so see carefully. dV is equal to, in case of Cartesian I have written dx, dy, dz, but now we are in the cylindrical coordinate system, 3 differential lengths we have to multiply. Because of the change in rho, d rho is the differential length. Because of the change in phi, rho d phi is the differential length. Observe this one carefully. I did not write simply d phi, I have written rho d phi. Reason already just now I have given. Because of the change in z, dz is the differential length. If you multiply these 3 differential lengths, you will get the differential volume. So, total volume is given by V. By integrating these things, you will get rho d phi dz. Assume some rho, okay, rho value is r. In this particular problem they have given r. So, r dr, phi is anyway 0 to 2 pi, and z value also they are taking 0 to h. Okay. This is the volume integral. Now, I am splitting that 3 integrals wise. So, r is from 0 to r, this is r dr, phi is from 0 to 2 pi d phi, z is changing from 0 to h dz. Okay. Now, integration of r with respect to r is r square by 2 and limits also r only. So, you will get r square by 2 only into d phi integration with respect to, sorry, 1 integration with respect to phi is phi. If you substitute the limits 2 pi you will get, and integration of 1 with respect to z is z, limits are h. So, 2 will be cancelled, what you will get? Pi r square h. This is the volume of the cylinder, that is the thing.